Number 1. The Forgotten Specimen. In 2016 in Japan, scientists discovered a type of bacterium with an exceptional capacity to break down plastic. Among samples taken from a recycling facility for plastic bottles, a bacterial strain was isolated that had naturally evolved the ability to feed on PET plastic, the material used to manufacture most water bottles. Every minute, the equivalent of a garbage truck's worth of plastic flows into the oceans. This plastic doesn't disappear. Instead, it breaks down into micropieces that settle in the environment and in living organisms, from birds and fish to humans. However, this newly discovered microorganism, named Ideonella sakaiensis, offers a revolutionary solution. It can decompose the PET material into harmless compounds in just 6 weeks. This is a stark difference compared to the 450 years the material requires to naturally degrade. This microbial discovery was a rare glimmer of light, providing us with a powerful tool that may help eradicate one of the most critical pollution problems facing our planet. Number 2. The incorrect formula. In the early 1960s, a team of researchers was working on developing a new liquid with unique properties. While testing various solutions, the scientists accidentally mixed 2 very similar-looking containers and were surprisingly struck by the liquid forming an extremely excessive foam that far exceeded expectations. This foam, which resulted from a chemical serendipity, is what we now know as aqueous film-forming foam. This foam proved exceptionally effective at extinguishing fires, not just ordinary flames, but especially the large-scale liquid fuel fires that claimed hundreds of lives in airplane accidents. Before this revolutionary discovery, dealing with aircraft fires was extremely difficult, as water only served to spread the burning fuel, escalating the disaster. However, this foam succeeded in immediately forming an insulating layer, cutting off oxygen from the fire source and cooling the fuel, thereby preventing reignition. This action is akin to throwing a giant protective blanket over a massive fire. Today, this foam has become a mandatory component in fire trucks at all major airports worldwide, and it all happened because the search for one specific liquid accidentally led to the discovery of a life-saving substance. Number 3. The discovery of penicillin. In 1928, the microbiologist Alexander Fleming was returning to his laboratory in London after a holiday. Fleming was notorious for his untidy work habits, having left open petri dishes on his lab bench near an open window. Fleming noticed that one of the dishes, which was contaminated with a mold, Penicillium notatum, had developed a clear, bacteria-free halo around it. He concluded that the mold secreted a bacteria-killing substance, which he named penicillin, derived from the fungus's name. It was the first broad-spectrum antibiotic. Despite this important initial discovery, Fleming was unable to isolate and stably purify penicillin for widespread medical use. However, nearly a decade later, in 1939, a team from Oxford University, led by Howard Florey and Ernst Chain, successfully purified, concentrated, and developed the substance as an effective treatment. This joint effort led to the mass production of penicillin, which has saved countless lives, revolutionizing the field of medicine. In recognition of their pivotal work, the 3 scientists shared the Nobel Prize in Medicine in 1945. Number 4. The alarm that did not go off. On September 26, 1983, Soviet Lieutenant Colonel Stanislav Petrov was on duty at the Soviet Air Defense Forces Early Warning Center. The then-secret and new satellite system indicated 5 American intercontinental ballistic missiles, ICBMs, were heading toward the Soviet Union. Military protocol dictated that such an attack called for an immediate nuclear retaliation. Although the computer system indicated an attack, Petrov decided the alarm was likely a system error, especially since the attack was only 5 missiles, which he considered too few for a comprehensive initial strike. He trusted his intuition and declared the warning false instead of reporting it to the high command. It was later confirmed that the system had malfunctioned. It was interpreting the reflection of sunlight off high-altitude clouds as missile launches. His decision to prevent an immediate response saved the world from a potential nuclear war. Number 5. The discovery of Teflon. In 1938, while working as a chemist for DuPont, Roy Plunkett was conducting experiments to produce a new refrigerant. He stored compressed tetrafluoroethylene gas in chilled containers. When he later found no gas emerging from one of these containers, Plunkett suspected the cylinder was empty. Driven to verify, the chemist decided to cut open the cylinder, only to discover inside that the original gas had undergone a polymerization reaction. The result was a white powder with a highly distinctive waxy nature, possessing superior resistance to heat and chemicals, along with exceptional slipperiness. This material, polytetrafluoroethylene, which became commercially known as Teflon, turned into a cornerstone in fields such as nonstick cookware, waterproof textiles, and critical industrial applications.